Hi, in this video we'll be continuing the H2 Mathematics 2021 paper 1. For question 8, it tells you for your concepts on vectors, and so we are given two equations of a line L1 and L2, and we're supposed to find the Cartesian equation for the plane containing both L1 and the point 1 minus 3 minus 1. So very simply, we know that there's a point in L1 with 3, 2, 0 as the coordinate. So we label that as OA. And then we just label the other point as OB. So the vector connecting A to B. So you can imagine the plane is this. You got your line here and B is here. O is this. OA is this. And the direction vector is 2, minus 3, 1. Then you just connect these two. And we see that this AB is minus 2, minus 5, minus 1. So why do I like to label an OA and OB? Well, it makes it very easy to remember how to find AB. AB is just you travel from A to O plus O to B. So it's like simply to remember it lah. So with AB, you just AO. So AO is always just minus OA. So that's 3 minus 3 minus 2 0. Then you plus 1 minus 3 minus 1. You get minus 2 minus 5 minus 1. And so then you want to find the normal vector. So you just take this vector and you cross multiply with this, or any multiple of this, cross multiply with any multiple of that. And then you will get 8, 0, minus 16. And how you get that is, well, you just take this times this minus this times this. So it's 5 plus 3. Then you hide the next row, then you take this times this minus this times this. So it's 0. Then you hide this row, then it's 2 times minus 3 minus 2 times 5. So that is minus 16. So then you can pull out the 8. So because you only care about the multiple, any multiple will do. So the simplest multiple is 1, 0, minus 2. And so the equation of the plane must be x, y, z times 1, 0, minus 2. Just take any point times this equals to 3. So then you expand this out. This means that x minus 2z equals to 3 is the Cartesian equation of the plane that you want. And now we want to show that L1 and L2 are perpendicular. And really that just means they just dot product the two direction vectors and see whether it's 0. And clearly when you dot product, it's 2 minus 6 plus 4. So it equals to 0, and this means that L1 and L2 must be perpendicular to each other. Next, we have to find the point such that R1 minus R2 is perpendicular to both L1 and L2. So what does this mean is that there are points. You got one L1 here and one L2 here. You're supposed to find points such that R1 and R2, so that, like points on the lines, so that when you take the vector connecting these 2 points, it's both perpendicular to both L1 and L2. And to do so, you just find a random arbitrary point L1 in terms of lambda and arbitrary point L2 in terms of mu. Combine them to get this vector. And then because it's perpendicular both L1 and L2, you can first dot product with the direction vector of L1, and you get what is lambda, which is minus 1. And then you dot product with the direction vector of L2, and you can able to simplify and show that mu equals to 1. So then you just sub lambda equals to minus 1 and mu equals to 1 to get R1 and L2, which is what they want. They state the position vectors, which is of the points where the common perpendicular meet L1 and L2. And lastly, they want you to find the length of this common perpendicular. Well, after finding R1 and R2, you minus them to get its vector. This is the common perpendicular vector. To find the length is just the formula where you square root of the sum of the squares of each coordinate. And what does that mean? You just square 4 plus the square 2 plus minus 2 squared, and then you just square root the whole thing. So this is like the generalized Pythagorean theorem. So I hope this question about vectors is clear, and if you have any question or doubts, please leave them in the comment section and we will answer them. The next question is testing us about differentiation and its applications as again. And so fx equals to ex cosine x. We are supposed to find the stationary point of fx. So first thing, immediately you just need to find the derivative, so it's f prime x. So you differentiate this using the power rule and you get ex cosine x minus ex sine x. Because when you differentiate ex, it's just ex, keep cosine, then now you plus, keep ex, differentiate cosine, which is minus sine x. So that's why it's minus sine x. Then now you must equate f prime x equals to 0. You pull out ex. Since ex is never 0, you can remove it. So it's just cosine x minus sine x equals to 0. And this can be reformulated writing sine x equals to cosine x. And since cosine x equals to 0 won't satisfy this because sine x won't be 0 at that point, we can just divide it over and we get tangent x equals to 1. So x must equals to pi over 4 because it's restricted between 0 to pi over 2 over here. Then you sub x equals to pi over 4 into f to get the value. And now we want to determine its nature. And so you just use the first derivative test to show that it is a maximum point. So you just go to calculator, type of pi over 4 minus like 0.0001. Then the other side is pi over 4 plus 0.001 and just check whether the derivative is positive or negative. Then you get positive, constant, negative. So the slope shows that it is a maximum point. Moving on, we will now have to integrate by parts and to show that this integral is this function in the end. So how do we do so? Well, when we integrate e2x cosine 2x, well, you can do it in multiple ways, but how I did it is really I keep the cosine 2x and then, so the formula for integral by parts, it's easy to remember, KI ID. So you keep integrate minus integral differentiate. So you keep cosine 2x, integrate this, which is half e2x, then you minus the integral times the differential of the what you have kept earlier, which is cosine 2x. So it's minus 2 sine 2x. Then you plus a c1, which is some random constant, and then you simplify it and you get this. Now you want to integrate this, but remember that you have kept the trigonomic term, so you must remember what you keep. So you must but now you don't get to choose, you must do the same way. So you keep sine 2x, integrate this e2x, which is half e2x, then you minus the integral times differentiate sine 2x, which is 2 cosine 2x. Then now your constant just change to c2. It's just a standard protocol. And then you simplify and then you get this value of this expression. So then you see that now you minus e2x cosine 2x, but here is also e2x cosine 2x. So what you do is you can bring this over, because this is a minus, so you bring this over, then this becomes 2 times the integral of e2x cosine 2x, then plus this chunk plus c2. Then you just divide the whole thing out and you actually get the result that you want. So you can see it's not that difficult, but we just need to remember that the integrating e is very useful because it just stays as e, and in the result that it does, you can get the third expression on the left hand side, on the right hand side to bring over, and that will help you solve the question. So these are some tips and tricks that you can take note of. And the last part about this question is we are supposed to find the volume of when fx is rotated about x-axis. So fx is e cosine x. So when you rotate this about the x-axis, you just use the formula pi y squared. So how you remember the formula is you randomly draw an fx, then the height of the strip when you rotate it, so like a is the height is y, so that's why it's y squared. Then you just rotate it pi r squared. That's the area. Then you just stack all the area up, you get the volume. So when you square this, it's just e2x times cosine squared, and cosine squared you can use the double angle formula to help you. And the reason for that is because you get a cosine 2x, and we already know how to integrate this. We already done the tough part about it in the question earlier, so that's why you want to do it. And by practicing more, you'll get the hang of when you want to use the double angle formula or when you want to integrate directly, because you are more familiarized with the tricks in the exam. So with this, you get this part and this part. Then you integrate to e2x is simple. Again, it's just half e2x. As for the next part, we already done the integral, so you can just pull back what you have done, and then you just sub in the values and make sure you don't have a careless mistake, and you get pi over 8 times e pi minus 3. So that'll be the end for this question, and if you have any doubts on this, just leave it in the comment section below, and I'll see you again. So please like, share and subscribe. I'll catch you in the next one. Bye.